Okay, we are on to lesson 4.5, parallel and perpendicular lines. Okay, so parallel lines. We're just going to be learning how to write the equations of parallel lines. So let's start. It says graph the lines y equals 5x plus 3 and y equals 5x minus 7. So for the first line, my y-intercept is 3. So I'm going to start at 3. And my slope is 5 over 1. So I'm going to go up 1, 2, 3, 4. Oh no, looks like I'm going to be off the graph. So instead of going up and over, I'm just going to go 1, 2, 3, 4, 5, and back. 1, 2, 3, 4, 5, back. Right, because it is the same slope either way. Next one is 5x minus 7, so we're starting at 1, 2, 3, 4, 5, 6, negative 7. And our slope is also 5 over 1. So we go up 1, 2, 3, 4, 5, and we go over 1. 1, 2, 3, 4, 5 over 1. So hopefully you notice something about the slopes of these lines and that they're the same. The slopes of these lines are the same. They look the same, they're just in different spots on our graph. What do you notice about the y-intercepts? Where do they cross the y-axis? In different places. Okay, one crosses at 3, one crosses at negative 7, but their slopes are the same. What kind of lines would they be if the slopes and the y-intercepts were the same? Well, they would be the same line. They would be layered directly on top of each other, okay, because it would be the same equation. So we're going to talk about writing equations of parallel lines. It says write the equation of a line that is parallel to I and passes through P. So it's parallel to this equation but passes through this point. Well, what do we now know about parallel lines is that they have the same slope. So parallel lines have the same slope. So if we're looking at this line as our original, what is the slope of this line? Y equals x minus 2. Remember, the slope is the number in front of the x, and in this case, our slope is just 1, or 1 over 1. And we know that our new parallel line has to have the same slope of that first line. So we have a slope of our new line, and we also have a point that our line goes through. With that information, we can do point slope form. Y minus y1 equals m times x minus x1 because we have a point and a slope. Eventually, I will want it in slope-intercept form, but because we're given a point and a slope, why not start with the easier equation? So y minus y1, which is 4, equals m times x minus x1, which is 1. From here, I want you to put it into slope-intercept form. And in order to do that, we need to distribute and solve for y. So y minus 4 equals 1x minus 1. Then add 4, y is equal to 1x plus 3. And that is an equation of a line parallel to this line, but that goes through this point. The only information that you need from the original equation is what the slope is. That is the only information that you need. Once you identify the slope, use your slope and your point, put it in point slope form, and then solve for y to get it in slope intercept form. So if we were to graph both of these lines, they should be parallel, meaning that they never intersect, right? Parallel lines never intersect with one another. Let's go through another example. Find the equation of the line that passes through the given point and is parallel to the given line. We are going to do this example right here. Example number 3. So, if we know that the new line is parallel to this line, then the slope of my new line is going to be the same as this line, okay? Because the parallels are the slopes are the same. So m is going to equal -8, just as it does with this line. Once we get that information from this line, we can get rid of it. That's the only information we need from that line. Now we have enough information. We have a slope and we have a point. Eventually, I want this in slope-intercept form, but to make it easier, let's first put it in point-slope form, since we have a point and a slope. So we have y minus y1 equals m times x minus x1. So y minus -4 equals m, which we found to be -8 because the lines are parallel, times x minus 1. From here, I want to put this into slope-intercept form. So we can simplify this, and we can distribute. Always distribute first. We get -8x plus 8. Then in order to get this into slope-intercept form, we need to subtract 4. And we get y is equal to -8x plus 4. So now we have a line that is parallel to the original line, but goes through this point.